Assalamu alaikum. Our today's class is actually the continuation of our previous class. In our previous classes, we have got the concept of clearance. We assume its definition and also its units. Then we move towards the different concepts of calculations of the clearance, how can we calculate, and then we assume the different formula for the calculations, and in the next class we clear our concept regarding the models and the compartmental, non-compartmental and physiological based approaches of the clearance. We assume that the units of the clearance are constant in each and every case, means ml per hour, ml per second. Volume and time units are actually the units of the clearance. Now today we will move another concept of some classification of the clearance and also its other definitions, because clearance can be classified according to their organ values. For example, when we assume that we have the clearance its definitions maybe with two concepts. One is rate and concentration concept, and other is volume concept, in which we will read about the tank and faucet analogy. Okay, in case of rate and its concentration concept, we can divide it into different subclasses. One is systemic clearance. Renal clearance, metabolic clearance, and hepatic clearance. Systemic clearance can be calculated by non-renal plus renal. Means these are the basically those types of the clearance. When we discuss the volume of the plasma which is getting freed from the drug, will be called systemic clearance. And if we are using the kidneys for this purpose, then we will use the word renal clearance. And when we will use some metabolic concepts, in my previous classes I have already told you, this concept is also can be converted into two: enzymatic and non-enzymatic type of metabolism. Clearance is actually the type of elimination, and in case of elimination we have studied the change in the drug. Either drug is passing out from the body or drug is converting it to its metabolized. So in case of systemic clearance, we will say it's a ratio between the rate of change of concentration with respect to time with the plasma concentration. Renal clearance is actually the type of clearance in which the same process is involved by with the help of the kidneys. And metabolic is for the sake of metabolism. And in case of hepatic clearance, we have a concept of use of the liver, because liver is mostly using for the sake of biotransformation and the metabolism concept. So this is the hepatic clearance concept. Our today's class is actually the focus of the other one, volume concept, tank and faucet analogy. We will study in this concept the drug as is following the first order rate kinetics. When we are assuming the concept of clearance, we will observe that the concentration with respect to time is decreasing and also the rate is also decreasing. It means concentration in the start is higher in the particular area, but with the passage of time the concentration is decreasing and the rate will also be decreased, so clearance will also be the affected. Okay, now we will move towards our tank and faucet analogy, which is a concept regarding the volume change, volume clearance, plasma clearance. Okay, this is actually students, this is actually our lab. Lab work will also be designed from the same concept. So I hope you will understand my concept and then you will observe when you will be present physically here in our labs and you will perform the same experiment by using the apparatus which we have designed in our lab. Okay, for example, we will assume that there are the two boxes, two mediums having the same volume, and we have the drug solution in the both solutions. One box is colored, having the dark color due to the high concentration of drug, and the other box having the same concentration, same volume of the drug, but the color is as compared to the first one is comparatively lighter. We have exit way here, one drop, which is 1 drop per second, and 1 drop per second means drug solution having concentration leaving 0.05 ml per second. And same way we have a reservoir of the medium and we are adding the 1 drop or 0.05 ml of the plasma of our solvent. Same procedure is here. This is our initial procedure at start. At start, what we have done, we have taken some volume of the solvent, either it's water or the buffer, and dissolve the drug and put into in this apparatus. In this apparatus, we have two different inner and out ways. In case of outer ways, we have constant flow 0.05 ml per second, means we have adjusted the volume of the 1 ml per second. 1 drop per second, and 1 drop per second is 0.05 ml per second. As we are getting out the solution of the drug from the 0.05 ml per second from this, we are adding the solvent 0.05 ml per second with the same scenario. At the time t0, when the time is, and at the initial time, we have the maximum concentration, and as the time passes, we are calculating the amount of 0.05 ml per second continuously, and same we are adding some drops 0.05 ml per second. So after few minutes, after few hours, we have our first physically change we will observe. That change is the change of color. For example, we are discussing with the drug which is colored, for example, nimesulide, which is light yellowish in color. When we make a concentrated the solution of nimesulide, say 100 ppm solution of nimesulide here, and this is at time, initial time is 0. So at time, after 1 hour, the situation is this one. First change we observe is the change in the color. Why we are observing the change in the color? Because we are diluting the solution now. How we are diluting? Because we are adding the same amount of the plasma, same amount of the solvent, and same amount of the drug is getting excreted from the system. Okay, what we want to learn? We want to learn is, because in our clearance concept, concentration of drug in plasma is a factor which is involved. As we have learned the formula of the clearance, that was rate of change of concentration with respect to time over Cp. That Cp is directly involved. So when we have the maximum concentration, then we have the inverse with it's the clearance. And as we are getting the Cp level decreased, then we will assume that we have the same effect with the clearance. For example, we will check the plasma concentration here first, then we will check the plasma concentration in this case. In this case, we can write, we have the, at time t1, tank is full, it contains a volume V of 1 liter of drug solution at concentration Cp1. So volume, what are the common things in it? Volume is 1 liter. Here also volume is 1 liter. And other is clearance is, because we know it's a rate 0.05 ml per second, and clearance is 0.05 ml per second. Clearance is same. And what about the K, rate constant? K rate constant is, K is clearance is equal to KVD, and clearance is equal to K is equal to clearance over VD. So clearance is 0.05 ml and VD is 1 liter, it's actually 1000 ml. And we can write the K value is 0.tetra05 per second. It's rate K. Okay, coming toward here, K is clearance is equal to KVD and K is equal to clearance over VD. So clearance is 0.05 ml and here is 1000. Answer is 0.tetra05 per second. So we assume that in both times, either we are starting the apparatus and at the end, even after few time, we have the same, some parameters are same. What they are same? Volume is same. Why it's same? Because as we are adding the same volume of the solvent and removing the same volume of the concentrated solution. Same with this one. And clearance is because we have adjusted the clearance 1 drop per second, which is actually the constant value. So what is the difference? Well, how can we assume that the difference is, according to this formula, when we want to calculate the Cp, we should have to put Cp is here and this one is here. Then our Cp is minus dxt over rate dx over dt over clearance. So when we divide this Cp, this concentration, and we will get 0.05 ml is our concentration, and this rate is now minus. For example, when we write this on the top, and we assume that this is clearance is equal to minus dx over dt over Cp. Okay, we can write here is Cp1. Cp1 is equal to Cp1 can be calculated by just multiplying this with the clearance. Cp1 and clearance is equal to our rate. Here we can write the word Cp2. Why we are writing the Cp2? Because we are calculating it after few time. Then our concentration is clearance is equal to dx over dt over cp2. Okay, cp2 into clearance is equal to minus dx over dt. As we are observing that concentration at the start is higher, cp1 is higher as compared to the cp2. So we assume that this ratio will be higher in the first case, but it is lower in the second case because we are eliminating some amount of drug. Same procedure is being performed in our body. For example, these two tanks are like our kidneys, and drug is approaching through the drug is present in the form of solution in our kidneys, in our blood circulation, and some extra volume is adding continuously as we are assuming the particular volume of the plasma is clearing within the irreversibly in a particular time. Then if we have the same concept of clearance, if we have the maximum concentration, then our rate is different at the start and this rate is different at the few times. Why it's different? Because the concentration is different. So we can assume that this is the phenomena which are depending on the concentration. And when they are depending on the concentration, then we can assume that this is the first order rate kinetics assumption of the this type of the example. So we can say that mass eliminated per unit time is not constant because we have the same volume of the plasma, it's constant, okay, volume distribution. We have the same clearance, okay, rate constant is same, but the mass which is transferring from the body through the clearance is considered to be not in the constant manner. This case is especially give us the concept of the first order kinetics. Okay, this can be zero order. In which sense? When we are assuming that these two tanks, for example, in this tank, we first make some freezing and we are just peeling one piece which contains this amount of the drug, which contains this type of the 0.05 ml per second or the particular amount of the drug. Then we can assume that the drug is completely eliminated and there is no effect of the concentration. So in case of our reality and the actual phenomena, we can assume that this type of the calculations will give us the sport drug is moving through the first order rate kinetics. Okay, next is our organ clearance, which was we have already explained in our previous lab when we previous class when we discussed the concept of our physiological model based clearance, where we have assumed that there is some effect of the efficiency or the extraction ratio of the organs. If the organs are working particularly on the different phenomena in the form of metabolism, just like the liver, then we can assume that calculate its extraction ratio and multiply this extraction ratio with the plasma flow rate, and then we will get the clearance of the drug. Okay, we will move towards our concept of the organ. For example, we are discussing with that organs which have the property of elimination. Organs capable of eliminating drug. Organ capable of elimination. Okay, what we will study? We will assume that this is Q flow rate or our cardiac output, which is our blood circulation or the plasma volume which is approaching to the organ, and we have Ca, that is concentration of drug in arteries, arterial blood. Okay, the other is the amount of blood which is getting out from the organ and moving towards the cardiac system, and we will write it here is a CV, concentration of drug which is present in the venous blood, and here is also our Q, our plasma flow rate, and then there is also the elimination rate. Okay, what we are studying now, we want to check what will be the effect of the extraction ratio, how this extraction ratio will give us the exact calculation of the clearance, and how can we assume that this extraction ratio will after few times, after some times, we can calculate the how many molecules of the drug is getting metabolized, getting eliminated, or getting cleared from the system. Okay, for this we will have to assume an example. In this example, we will assume that there are the number of 10,000 molecules of drug. For example, 10,000 molecule of drug which are giving to the patient, which we are assuming that these are the dose of the drug which are given to the patient, and volume of distribution of drug is 12.5 liter. And now when we assume that there are the two different pathways, in this case, there are the first case is there is no any type of the organ clearance involvement. Then the passage will be very simple. This type of the say, for example, we will calculate that this is our cardiac system and cardiac output. Same with this cardiac output. With moving with the same scenario, and no renal, no clearance pathway. And same, the process will be moving without any type of the clearance. We will studying how the organs are involved in the concept of clearance. There are the two scenarios. One is organ is not involving, means there is no any type of the clearance. As the drug is moving with the blood or the plasma getting out from the same organs without any type of the where it's biotransformation or its metabolism. So the concept is very simple. It's cardiac output, and then its flow rate toward the hepatic system. Then we will there is no any type of the clearance. Same with the same scenario, having the same number of molecules of drug which are passing. Okay, another concept in which we are assuming that the drug is approaching towards the liver. Then we will assume that this QH is flow rate of the drug towards the hepatic system, and this hepatic system have the, for example, now we have 10 molecules. Here once again, there may be two systems. One is some molecules are escaping from their metabolism, and other molecules are just getting their metabolite forms. So we will make the two different ways. One is, say, for example, two of the 10 molecules which are approaching to the liver are getting metabolite. So how we can calculate its extraction ratio? 2 by 10, which is 0.2. And 8 molecules are escaping without any metabolism. These 8 molecules are escaping without metabolism. Now we have these 2 molecules which are metabolite, which are coming from this path, and 8 molecules which are coming from the same organ is same, but some molecules are showing getting their metabolism and some molecules are just escaping. We in our previous diagram, we have the concept that drug is not involving any type of the organ clearance. In the second step, we are assuming that organs are involving in the step of the clearance. So we can assume that there are the 2 further pathways. Some molecules are getting their metabolites, converting into metabolites, but some are not converting, are just escaping. So we can write here, this is the extraction ratio. If we know this Q value, we will multiply this Q value, which is actually the plasma flow rate, with this E, we will get the organ clearance. We will get the hepatic clearance. Okay, then this will move there, this system will move towards the cardiac output, and then once again into the cardiac system, and then once this cycle will be once again. From this cycle, what we learn? We will learn 2 different concepts. For example, if we know the amount of plasma which is getting in and out are same. For example, we have Q in and Q out to the organ. Q in is equal to Q out is equal to 0.0125 liter per second, which is approaching. And we can calculate the plasma concentration, or the plasma concentration is actually the number of molecules which are approaching. We are assuming that there are 10 molecules per second which are approaching to the liver in our previous example, and because we know it's formula of X over Vd, this is our X and Vd is our 0.0125 liter, sorry, this is not for this, 0.0125 liter, and our Cp is total 800 molecules per liter. Remember, I once again told all of you what we are learning. We are learning organs are involving in the clearance. First, we assume that there is no any type of the organ involved in the clearance. Okay, same number of the molecules which are approaching to the organ within the plasma will be getting back towards the cardiac system, systemic system without any type of the change. First condition. Second condition is drug is getting some metabolite are the approaching that organ which are involving in the type of the metabolism, for just like the liver. Then there are the 2 categories of the drugs, 2 categories of their molecules. One is getting metabolite and one is getting escaped from the system. So we have the Cp here 800 molecules per liter now. This is our actual condition. And what will be our volume of distribution? Volume distribution is dose which I have written in the start of this experiment, that was 10,000, 1 into 10 power 4, and then it's 800, it's Cp. Then we have the Vd, which is 12.5 liter. Vd of the drug is 12.5 liter. Now we can check we have the efficiency in the form of E value, that was 2 by 10, efficiency or the extraction ratio, that was 0.2. So we have now Q and also the E. We can calculate the organ clearance here. Organ clearance is now Q into E, which is Q is our flow rate 0.025 ml liter per second multiplied by 0.2. So clearance is 0.025 liter per second. we have used one formula and assuming that we have the clearance value 0.025 liter per second. This is the first condition. Okay, in another way, when we move towards the clearance is equal to KVD, which we have written the formula in case of compartmental concept, if you remember, that was the formula in our physiological modeling concept. And then we will calculate K first. K is our fraction of drug, which is metabolite. So K can be fraction of drug metabolite which is 2 over 1 into 10 raised power 4. How much molecules are now metabolite? Then K answer is K is 2 into 10 raised power minus 4. Means K is 0.0002. It's K. So now we have the VD, this one, and we have the K. We will multiply this K and VD, we will get the clearance value. That clearance is KVD. Okay, we will get once again K is 1 into 10 power minus 4 K and VD is 12.5 and our clearance is now same 0.025 liter per second. By using the two different formula, we have obtained the same answer. When the drug is getting metabolized, the drug is getting converted into the different. Okay, we have another formula for the clearance, which we have learned in our previous class. That was the rate and CP. Okay, the rate clearance is delta X over delta T over Cp. So our rate is 2 molecule per second and Cp is 800 molecule per liter. Answer is once again 0.025 liter per second, which is the value of clearance. So how the formula which we are using the formula for the compartmental, our physiological modeling approach QE. We have obtained the same value of the clearance, that was the 0.025 ml liter per second. Same with the KVD, same with the rate equation. Now we will move towards after few time. For example, after passing some time is 1 hour. What will be happen after passing 1 hour? When we assume that where the concentration is, because concentration after the 1 hour will be reduced, and as the concentration will be reduced, then our clearance will also be reduced. Our clearance values will also be changed. And how they will be changed, I will give you an example. For example, first of all, we will calculate the Cp at 1 hour. And we want to know the concentration of, we have the formula of Cp is equal to Cp naught E minus Kt. And this T is now 1 hour, and we will write 3600 seconds. And our K value is which is 002 per second, and our Cp value which we are assuming that Cp naught is 800 molecules per second, okay, and molecule per liter, and getting the exponential of all these, we will get the Cp at time 1 hour. That value is 389.4 molecule per liter now. I will construct a table, then we will assume that what we are doing now. For example, we are discussing the different parameters of the concepts. First is Cp, other is clearance by organ. Okay, clearance we will write the combined. Volume of distribution VD, okay, its extraction ratio, okay, its clearance by organ method, clearance by compartmental method, and then clearance by rate method. Okay, these are the two different parameters at start. And now what we are calculating after 1 hour. After 1 hour. So first of all, Cp was 800 molecule per liter. We have already calculated it in the start. And now these Cp value is now 389.4 molecule per liter. It means, as we have taken the example of the tanks, and we assume that these two concentrations after few time are not constant. Why they are not constant? Because we are getting diluted the system. We are getting the more solvent into the system. And when we are getting the more solvent in the system, we are getting some decreasing in the concentration of the system. Okay, what will be the VD? VD in case of our previous calculation, that was 12.5 liter. And in the same scenario, when we calculate this with the example of different concepts, we have the same VD, that was 12.5 liter. It means volume of distribution is same. Either we are studying the drug for the concept of clearance at start, or we are studying the drug for the concept of clearance after 1 hour. Okay, what will be the number of molecules of drug? X, that is, so we have to multiply this X is Cp with the V, because Cp is equal to X over Vd. Then Cp is, we have this one, we can check the X value, amount of number of molecules value, we can write it, it's in the start, number of molecules. Both are different. Both are different. When we multiply this one with this, we will get, these are the 4,868 molecule. Remember, in our, when we multiply this one, this into this, 12.5 into 800, then remember we are starting with the how many molecules? 10,000 molecules. 10 to the power 4 are the 10,000 molecules. So we have the same, this one amount, number of molecules, these are the now changed. Why we have the number of molecules changed? Because these molecules are the now getting freed, getting out from the system, moving towards the clearance concept. But we have the difference in the concentration, but we have the same values of the this VD value 12.5 liter. Okay, when we calculate the rate dx over dt, that would be also be changed. when in our previous dx over dt was, which we have calculated, was the 2 molecule per second. But in this case, when we are getting the some Cp value, because we know in the case of calculation of the clearance is equal to dx over dt over Cp, then this rate is dx over dt clearance into Cp. So this rate is changed. In our previous, we get the 2 molecules per second, and now in this case, we will get the less than 2, which is 0.973, because when we multiply this value of the Cp with the clearance, we will get the 2 molecules. Okay, we can make another parameter here. Okay, dx over dt value. It's 2 molecules per second in the start, but it is decreased into 0.9735 molecule into per second. So another change, ratio. Now when we move towards the further concept of clearance, we will get its extraction ratio, which is 0.2 at time t, and then our other values of the clearance are, we are getting the multiplication of these two after 1 hour, and our rate is now 4.86 per mole, and efficiency is once again drug elimination rate over rate is, then we when we calculate the at time t efficiency drug elimination rate over rate of drug in is, we will get 0.2. So E is the same at time t and t1 hour. This is 0.2 and 0.2, because we assume that 2 molecules are moving and 10 molecules are moving, but 2 molecules are getting metabolized. Here are not 10 molecules, less molecules are moving and less getting the metabolite, so our efficiency will be our concept will be same. Now we can calculate by using these equations, clearance of the organs, clearance by the compartment, and because we have the value of, for example, clearance of organs Q and E. Q blood flow is the same in the both cases. When we multiply this with the QE, and then we are getting the same, and same answers we will get in our, by using this. This is our assignment to calculate the clearance of these 2 parameters by checking this, because we will get the same value of 0.025 mole per second, molecule per second, and then liter per second, sorry, and 0.025 liter per second, 0.025 liter per second. Okay, what will be the answer for these? For the organ, for the other, the answer will be the getting the multiplication of this 0.2 with this, and the same answer we will get. Why we are assuming that clearance concept have the effect of the as we are moving toward the change in the concentration. We have changing the amount of the number of the molecules, concentration of the drug in the plasma, having the same VD, same efficiency or same extraction ratio of the drug. Rate is now different. When we divide dx over dt with this Cp, we will get answer. Can we divide this 0.973 with this one? We have this almost same answers by checking this concept. So this is about the concept of our Faucet analogy and the it's a fluid tank model, which is it's actually our practical performance, where we will construct some solution of the drugs which we have given to the different groups, and then we will assume adjust the apparatus and then understand this. If you have any question, then you may ask me in my in the inbox of and also in my comments of my video. Thank you very much.